Hey guys, welcome to Technozar. This is Rohit Sharma, and in this video we are going to solve Ursc 2019 paper. Okay, this paper will be completed in four videos. Okay, in first video we will complete from question number 1 to question number 20. Okay, so let's start the video. First question number 1: the light is confined with the core of an optical fiber due to refraction, scattering, diffraction या total internal refraction at the core cladding boundary. Suppose the light in the optical fiber, this is the cladding. Here it is a mirror image. Okay, these are the mirror line walls of the cladding. Okay, here the light bounces back like this. Okay, and reflected in the core cladding. Therefore, the light is confined within the core of an optical fiber due to the internal reflection at the core cladding boundary. Okay, so option D is the correct answer for question number 1. And this is also the principle of total internal reflection. Next, one of the main application of capacitance is, first of all, capacitance stores the energy in the form of electric field. Okay, this we all know that. And secondly, it operates only on AC voltages. Therefore, capacitance blocks DC and pass AC. Option C is the correct answer. Next question. This question is very important. They have said that this is a 10 ohm resistance. This is 40 ohm. This is 25 ohm, and this is 25, and this is 10 ohm, and the resistance between these two nodes is 50 ohm. Okay, they have said we have to find the equivalent resistance from A and B, that is RAB. First of all, we will check the bridge is balanced or not. 10 into 10 is equal to 25 into 40. 10 into 10 is 100, but 25 into 40 is 1000. Therefore, the bridge is not balanced. Now, this means that the current will flow here. Therefore, now we have to convert this delta into star here, like this. Similarly, like this. Okay, to convert delta into star, suppose I am saying this is R1. Therefore, R1 is equal to 10 into 40 upon the sum of the total resistance of the delta, that is 10 plus 40 plus 50, which is equal to 400 upon 100. Then this resistance star R1 is equal to 4 ohm. Similarly, we will calculate all the resistance in star. Okay, on calculating this, we will get this resistance as 4 ohm, this. Okay, this we will get as 5 ohm, this we will get as 20 ohm, this will 1250 upon 85, and this will be 500 upon 85, and similarly the last resistance will be 250 upon 85. Now these are in series. Now I am redrawing the circuit. This is 4 ohm. In series, this will be 19.70. In series, this 20 plus 500 upon 85, this will be 25.88, and last one is 2.94. Okay, this is 85, 250 upon 85, 2.94. On this, these are in parallel and these all are in series. On calculating this, we will get around 18.12 ohm. This will be approximately equal to 19 ohm. This is how we can calculate this question, and this is the very important question. First of all, we have to convert delta into star, and then star connections are in parallel, like these connections are in series. This is also in series, then they are in parallel, and after then they all are in series. This is how we can calculate this question, and answer B, option B is the correct answer. Question number 4. Question number 4 is, current in an intrinsic semiconductor is equal to the electron current plus hole current. Okay, because in intrinsic semiconductor, the number of free electrons in conduction band is equal to the number of free electron in valence band. Okay, remember this, in valence band. Therefore, the current caused by the electron and the current caused by the hole are equal in magnitude. Therefore, the current in a intrinsic semiconductor is equal to the sum of the electron current plus hole current. Option C is the correct answer. Next question. When we tune in any desired station in a radio receiver by rotating the tuning control, we vary the capacitances. There is a change in capacitance. Okay, when we this is a capacitance. This is the air-filled capacitor. Okay, air-filled capacitor. Okay, when we tune in any desired station, these plates, there will be a change in the plates. Okay, there will be a change in the surface area of plates. Okay, and we know that capacitance is equal to epsilon A upon D. If there is any change in the area or any diameter, then the capacitance will also change, and the desired station will change. Okay, this is how we can get this answer. Therefore, option B is the correct answer, that is the capacitance. Question number 6 is saying a glider goes from a position 30.4 cm to 113. Therefore, the distance he covered is 113.0 minus 30.4. Okay, this will be equal to around 82.6. 82.6. Now, the time taken to travel this distance is 5 by 3 minus 1 by 3 second, which is equal to 4 upon 3 second. And we know that the average velocity or speed, we can say that displacement or distance upon time taken. Distance is 82.6 upon 4 upon 3. This will be 82.6 into 3 upon 4. Now, on calculating this, we will get 61.95 centimeter per second, because the distance was given in centimeter and the time is in second. Therefore, option B is the correct answer. Next question. Question number 7. Force causes acceleration on a body. B. Why? Because force, we know that according to Newton's second law of motion, force is equal to mass into acceleration. If there is a change in force, then the acceleration will also increase, because they both are directly proportional, because the mass of body is always constant. Okay, suppose there is a car here. The mass of the car is always constant, therefore the force will be directly proportional to acceleration. If we put some force on this body, the body will accelerate. Okay, next question. Question number 8. Which of the following colors of light has the greatest energy per photon? Option C, violet has the greatest energy per photon, because the shortest wavelength, the light which has the shortest wavelength has the greatest energy per photon. Option C is the correct answer. Next question. The ratio of the magnitude of the applied force to the cross-sectional area stress is always equal to force upon area. Remember this. Therefore, option B is the correct answer. Question number 10. Which of the following is not a fundamental quantity? Fundamental quantity are defined by mass, length and time only. Okay. Therefore, perimeter is the correct answer here. Next question. A 20 kg block is placed, that is mass is given to us 20 kg. A horizontal force, that is 20 Newton is given, is applied to the block. The position of the block at 5 seconds, that is time equal to 5 seconds. We have to find the position of the block, that is the distance, s equal to what? Okay. From here we know that F is equal to mass into acceleration. So force is equal to 20, mass is equal to 20 into 20, acceleration is equal to 1 meter per second square. Okay, this is 12 Newton. Sorry, this force is 12 Newton. Therefore 12 is equal to 20 into A is equal to 12 upon 20, which is equal to 0.6 meter per second square. This is the acceleration. Okay, now we know that S is equal to ut plus half at square, which is the second equation of motion, and we know that the position of block at 5 seconds. Okay, initially I have taken that the Position of block initial is at rest. The block is at rest. So 0, u is equal to 0 into time is 5 plus half. Acceleration is given at 0.6 into time is given at 5, that is 5 into 5. On calculating this, we will get 25 into 0.6 upon 2, which is equal to 7.5 meter. Therefore, 7.5 meter is the correct answer, option B. Next question. Which of the following statement is correct? 4 cross 1 multiplexer. We know that this is a 4 cross 1 multiplexer, and 4 cross 1 means 4 inputs are given and we get 1 output, and there will be 2 select lines. Okay, therefore a 4 cross 1 multiplexer has 4 output line, 2 select line and 1 input line. This is wrong. 4 output line means 4 input line. A multiplexer has 4 input line, 2 select line and 1 output line. Therefore option A is the correct answer here. Next question. Okay, which of the following statement is correct? Remember this, for transmission channel, PCM, the pulse coded modulation, needs high bandwidth. It needs high bandwidth. Okay, whereas DPCM needs less bandwidth. Okay, in PCM the 7 bits are transferred per 8 sample, whereas in DPCM 4 bits are transferred per 6 sample. Okay, sample. Therefore PCM has high bandwidth as compared to DPCM. Therefore option C is the correct answer. PCM bandwidth requirement of DPCM is less than the PCM. Okay, next question, question number 14. The electric field due to a point charge at a distance r. We have already learned this formula. Electric field is equal to kq upon r square, where q is the charge at that point, r is the distance, and k is the Boltzmann's constant. K is constant, q is also constant. Therefore I can say E is inversely proportional to r square. Therefore option D is the correct answer. Okay, E is inversely proportional to r square. Next question. These all are aptitude question. A car initially is traveling at 30 km per hour. Okay, initially that is u 30 km per hour. On changing this into meter per second, I am getting 8.3 meter per second. Okay, the initial velocity is 8.3 meter per second. The constant rate is 1.5 meter per second square. Meter per second square is the unit of acceleration. Therefore acceleration is given as 1.5 meter per second square. How far the car traveled in 15 seconds? T is given as 15 seconds. We have to find the distance. This here we will put this formula as ut plus half at square, and u is given as 8.33 into t is given as 15 plus half, a is given as 1.5 and t is given as 15 into 15. On calculating this, you will get 293.75 meter as the distance covered. Therefore option D is the correct answer. Question number 16. A transformer. Okay, we are talking about transformer here. So we are drawing a transformer here. This is the primary winding and this is the secondary winding, and this is a trans ratio, that is N1 is to N2. Okay, and we know that transformation ratio is equal to V1 upon V2 is equal to N1 upon N2 equal to I2 upon I1, also E1 upon E2. Okay, this is transformation ratio. They have said the primary winding is connected to 230 volt. This is 230 volt. Okay, they have said to find the induced EMF, that is E2. Okay, you have to find E2. E1 is given as 230. So I can put the formula here. E1 upon E2 is equal to N1 upon N2. Okay, we have to find E2. Then E2 is equal to E1 into N2 upon N1. E1 is given as 230 into N2 is given as 1050 upon N1 is given as 350. Okay, on solving this you will get 690 volt as the correct answer. Therefore option A is the correct answer, but you are seeing that option A also has 690 volt and option B also has 690 volt, but the frequency here is 50 Hz and there is 150 Hz. always remember that transformer is a constant frequency and power device. That means at both the end the frequency will remain same and the power also remains same. Therefore, at primary the supply is 50 Hz, then the secondary also will have 50 Hz. Therefore, option A is the correct answer here. Question number 17. If a transmission line is terminated with a resistance equal to its characteristic impedance, then the standing wave ratio will be minimum. What is standing wave ratio? Standing wave ratio is a measure of impedance matching. Impedance matching of loads. Impedance matching of loads to the characteristic impedance of transmission line. Okay, to the characteristic impedance of transmission line. Therefore, whenever a transmission line is terminated with a resistance equal to its characteristic impedance, then the standing wave ratio will be minimum. Therefore, option B is the correct answer. Question number 18. Express the power dissipated in a 100 ohm resistor in dB relative to 1 milliwatt when the voltage across the resistor is 1 volt RMS. Okay. Therefore, Vrms is given as 1 volt here. Okay. And we know that power is equal to Vrms square upon R. That is 1 square upon resistance is 100. Therefore, this is equal to 1 upon 100. Okay. This is power output. Output power. Input power is given as 1 milliwatt. That is 1 upon 1000. Okay. Now we have to find the power in decimal. Then 10 log P output upon P input. This is equal to 10 log power output 1 upon 100 upon 1 upon 1000. Okay. This will be equal to 10 log 1000 upon 100. This will get cancelled by this. Therefore, 10 log 10 and log 10 is 1. Therefore, 10 answer. 10 decibel is the answer. Power in dB will be 10 decibel. Option C is the correct answer. Question number 19. A tuned circuit at resonant at 4 MHz, its quality factor is 100. Find the bandwidth. We know that quality factor is defined as the frequency upon bandwidth. Then frequency is given as here 4 MHz, that is 4 into 10 to the power 6 upon bandwidth. I can take here and quality factor here. The quality factor is given as 100. This 100 will divide by this. This will be 10 to the power 4. Therefore, 40 kHz will be the bandwidth of the tuned circuit. Therefore, option A is the correct answer. Last question, question number 20. What is the modulation index in a frequency modulated signal with carrier frequency is given as 100 MHz. Modulation frequency, that is FM, is given as 4 kHz. And the frequency deviation, that is del F, is given as 50 kHz. Okay, we have to find the modulation index. Modulation index in a frequency modulated signal is given as frequency deviation upon the modulating frequency, that is FM. Del F is given as 50 kHz upon FM is 4 kHz. This will get cancelled by this. 50 divided by 4 is 12.5 is the modulation index. Therefore, option C is the correct answer. Okay. In this part first of Ursc 2019, we have covered around question number 1 to question number 20. If you have any doubts related to these questions, please ask me in our Telegram group and join our Telegram group ISROTA for ECE, and I will provide you the link in the YouTube description. And if you like the video, please share it with your friends and subscribe our channel. This is very important so that you can get further updates regarding our channel or regarding any exam related to electronics, electrical examinations. Okay, so all the very best, guys.